Hello guys, today I want us to learn about binomial expansion. We are doing one more illustration, and this is to find the independent term in a binomial expansion. The independent term in a binomial expansion is the term that contains x raised to power 0. Before we do this question, kindly check our previous videos on how you derive the binomial expansion formula all the way from the Pascal's triangle, so that you can understand this with ease. If you have checked the videos, kindly let's proceed and do this question. From the videos, we derived the binomial expansion formula, whereby we said that when you know the power of this binomial, then which in our case we shall call it n, then we can solve this. So we shall solve this by saying the formula, using this formula, n factorial, then you have r minus 1 factorial, then you have n minus r plus 1 factorial. So the solution of any coefficient or of any r term in this equation will be as follows. So we shall have this, we can call it our a. So we shall have a will be raised to this power. A will be raised to power n minus r plus 1. Then we shall have b, of which our b is this one, which will be raised to this power, which is r minus 1. So, since we know what is our a, which is x squared, and this, and we know what is our n, what we don't know is what is our r. And we want to find the term that contains x raised to power 0. To do so, we can solve this. This one we shall have n factorial divided by r minus 1 factorial, n minus r plus 1 factorial. Then here we know what is our x squared raised to power n minus r plus 1. Here we have 1 over x. From the rules of exponentials, we know, just recall this, from exponentials, we know that 1 over x is the same as x raised to power negative 1. So we shall apply that. So here we shall have x raised to power negative 1, which is now this. We have r minus 1, which should give us a constant or a coefficient. Then we shall have x raised to power 0. This means that this coefficient can be found using this. The x can be found using this solution. Recall something that from the rules of exponentials, any number raised to power 0 is simply 1. That's why we call this independent, the independent term in a binomial expansion. So we shall solve this in order to get r, since we already know n. Then from there we can know our independent term in this equation. Recall also from to solve this. Recall also when you are given a power 2, you multiply with a power 3 in the rules of exponentials. This is the same as a 2 plus 3, which is actually a power 5. So that means here we shall just pick the power and we plus this and we plus this, and we are able to get the solution. So we proceed on with that. So here we have, so we pick this. Okay. So we have 2. Then we have n minus r plus 1. Then we have here plus. Since you have said, if you take a squared multiply with a power 3, this is the same as a 2 plus 3. That's why we are plusing here. We have negative. Then we shall have negative 1, r minus 1, which should be equals to 0. There is 0 here. We can open the brackets. When you open the brackets, you have 2n minus 2r plus 2 minus r. This minus affects this one. Then this becomes plus 1 equals to 0. Since we know our n equals to 9, then you can substitute here. This means it's 2 multiplied by 9 minus 2r plus 2 minus r plus 1 equals to 0. This is 18 minus 2r, like terms together, minus r plus 2 plus 1 equals to 0. This is 18 minus 3r plus 3 equals to 0. This is 21 minus 3r equals to 0. Then you have 21 equals to 3, and take this to the other side, it becomes positive. You divide this by 3, we find our r equals to 7. So once we know our r equals to 7, we can find the independent term. We can find the independent term or the independent coefficient. So we have now, we go back to our formula, n factorial divided by r minus 1 factorial. Then we have n minus r plus 1 factorial. Okay? So we know what is n. So we know n equals 9, r equals 7. So now we can solve this. This implies that here we shall have 9 factorial divided by 7 minus 1. 7 minus 1 factorial. Then here we have 9 minus 7 plus 1 factorial. If you simplify this, here we get 9 factorial. Here we have 6 factorial. Okay. Here we have 7 plus 1. Here we have minus 7 plus 1. That becomes minus 6. So this becomes 3 factorial. Okay. If you solve this using a calculator, we can solve this using a calculator. You use your calculator, you put 9, then you have shift factorial. 9 factorial is 362,880. Then we have 6 factorial, which is 720 multiplied by 3 factorial, which is 6. Here you can find a solution. You solve this. (362,880) divide by 720 divide by 6. The answer is 84. This therefore means that 84 is our independent term. In this binomial expansion. Thank you. Be blessed.